Humankind has always been drawn to the stars, driven by an insatiable curiosity that has fueled our desire to explore the cosmos. From the earliest days of stargazing, when ancient civilizations mapped the heavens, to the modern era of space exploration, our fascination with the universe has only grown stronger, and the desire to explore the unknown. This relentless quest has led us to the brink of a new frontier, one that promises to expand our horizons and redefine our place in the universe. Now, the dream of reaching beyond Earth and establishing a human presence on another planet is closer than ever before. With each passing year, advancements in technology and science bring us nearer to making this dream a reality. Mars, our red neighbor, has emerged as the prime target for this extraordinary endeavor. Its similarities to Earth, such as the presence of polar ice caps and seasonal changes, make it a compelling candidate for colonization. Visionaries like Elon Musk, the driving force behind SpaceX, and organizations like NASA have made Mars colonization a central focus of their long-term goals. Their ambitious plans include not just visiting Mars, but establishing a permanent human settlement. Their vision extends beyond mere scientific outposts. They envision a future where humans can live and thrive on Mars, creating a self-sustaining civilization that ensures the survival of our species beyond Earth. This vision includes building habitats, growing food, and developing the infrastructure needed to support human life on the red planet. This ambitious goal is driven by a combination of factors: the potential for scientific discovery, the need to secure humanity's future, and the desire to push the boundaries of human achievement all play a role in this grand vision. The search for life beyond Earth, a question that has intrigued scientists for decades, is one of the primary motivations for exploring Mars. Discovering even the simplest forms of life on Mars would have profound implications for our understanding of biology and the potential for life elsewhere in the universe. The need to address Earth's growing resource constraints, such as the depletion of natural resources and the impacts of climate change, also drives the push for Mars colonization. Establishing a human presence on Mars could provide new opportunities for resource extraction and help alleviate some of the pressures on our home planet, and the fundamental human urge to explore and push the boundaries of what's possible. This innate drive has led us to achieve remarkable feats, from landing on the moon to sending probes to the far reaches of our solar system. All contribute to the allure of Mars colonization. The prospect of becoming a multi-planetary species captures the imagination and inspires us to dream big. It represents the next giant leap for mankind, a testament to our ingenuity and our enduring spirit of exploration. The journey to Mars is not just about reaching a new destination. It's about expanding the human experience and ensuring the long-term survival of our species. This journey to Mars will be fraught with challenges, requiring unprecedented technological advancements and a global collaborative effort. From developing new propulsion systems to creating life support systems that can sustain humans for extended periods, the challenges are immense but not insurmountable. But the rewards, both in terms of scientific discovery and the future of humanity, make it a pursuit worthy of our greatest ambitions. The knowledge gained from exploring Mars will not only advance our understanding of the universe, but also inspire future generations to continue the quest for knowledge and exploration. Transforming the barren landscape of Mars into a habitable environment for humans presents an array of formidable technological challenges. From creating breathable air and cultivating food, to generating energy and protecting against harmful radiation, every aspect of life on Mars must be meticulously engineered. One of the most pressing needs is developing sustainable energy sources that can power life support systems, transportation, and other essential infrastructure. Solar power, while abundant on Mars, is less efficient due to the planet's distance from the Sun. Nuclear power, with its long-lasting energy output, offers a promising alternative. Water, the elixir of life, is scarce on Mars, locked away as ice beneath the surface. Extracting and purifying this water will be crucial for drinking, growing crops, and producing oxygen through electrolysis. Innovative technologies that can efficiently harvest and process Martian water are essential for sustaining a human presence. Protecting colonists from the harsh radiation environment on Mars is another critical concern. Unlike Earth, Mars lacks a global magnetic field, and a thick atmosphere to shield its surface from harmful cosmic rays and solar flares. Specialized habitats, radiation shielding materials, and potentially even genetic modifications may be necessary to safeguard human health. While the allure of Mars colonization captures the imagination, it's essential to acknowledge the daunting environmental challenges that await us on the red planet. The dream of establishing a human presence on Mars is filled with excitement and wonder, but the reality is that Mars is an incredibly harsh and unforgiving place. The challenges are numerous and complex, requiring innovative solutions and advanced technology. From its thin atmosphere and extreme temperatures to its lack of liquid water and a protective magnetic field, Mars presents a hostile and unforgiving environment for human life. The planet's surface is bombarded with radiation, and the soil is devoid of the nutrients needed to support plant life. These factors make Mars a challenging place to live and work. Mars' atmosphere is about 100 times thinner than Earth's, composed primarily of carbon dioxide with only trace amounts of oxygen. This thin atmosphere means that there is very little air pressure, making it impossible for humans to breathe without the aid of life support systems. The lack of oxygen also means that fires cannot burn, which poses additional challenges for energy production and waste management. This thin atmosphere offers little protection from the sun's radiation and results in extreme temperature swings between day and night. During the day, temperatures can soar to a relatively mild 70 degrees Fahrenheit or 20 degrees Celsius, but at night they can plummet to minus 200 degrees Fahrenheit or minus 129 degrees Celsius. These extreme temperature fluctuations can cause materials to expand and contract, leading to structural damage and equipment failure. Temperatures can plummet to minus 200 degrees Fahrenheit or minus 129 degrees Celsius during the Martian night, posing significant challenges for human survival and technology. The cold can cause batteries to lose their charge, electronics to malfunction, and life support systems to fail. Insulating habitats and equipment against the cold will be a critical aspect of any Mars mission. The lack of liquid water on the surface is another major hurdle. Water is essential for life, and without it, humans cannot survive. The dry and barren Martian landscape offers little hope for finding surface water, and any water that does exist is likely to be frozen and buried beneath layers of soil and rock. While evidence suggests that water ice exists below the surface and at the poles, accessing and utilizing this water will require advanced drilling techniques and energy-intensive processing methods. Extracting water from ice will involve melting the ice and purifying the water, which will require significant amounts of energy and sophisticated equipment. Developing efficient systems for water extraction and recycling will be paramount to sustaining a human presence. Water recycling will be essential to minimize the amount of water that needs to be transported from Earth, and advanced filtration and purification systems will be needed to ensure that the water is safe to drink and use. Furthermore, Mars' lack of a global magnetic field leaves its surface exposed to harmful radiation from the sun and cosmic rays. This radiation can penetrate the thin atmosphere and reach the surface, posing significant risks to human health. This radiation poses significant risks to human health, potentially damaging DNA, increasing the risk of cancer, and causing other health complications. Long-term exposure to radiation can also weaken the immune system and increase the risk of other diseases. Protecting astronauts from radiation will be a major challenge for any Mars mission. Developing effective radiation shielding and countermeasures will be crucial for protecting Martian colonists. This could involve building habitats with thick walls made of materials that can block radiation, or using advanced technologies such as magnetic fields or water shields to create a safe environment. Ensuring the health and safety of astronauts will be essential for the success of any long-term mission to Mars. Among the organizations at the forefront of Mars colonization, SpaceX stands out for its ambitious goals and innovative approach. Founded in 2002 by Elon Musk, SpaceX has consistently pushed the boundaries of space exploration, aiming to make space travel more accessible and affordable. Led by Elon Musk, SpaceX is committed to making life multiplanetary, with Mars as the primary destination. Musk's vision is not just about reaching Mars, but about creating a sustainable human presence on the red planet. This vision is driven by the belief that humanity needs to become a multi-planetary species to ensure its long-term survival. Central to their vision is the development of Starship, a fully reusable spacecraft designed for interplanetary travel. Starship is unlike any other spacecraft ever built, with the capability to carry up to 100 passengers and a significant amount of cargo. This makes it a game changer in the realm of space travel. Starship represents a radical departure from traditional spacecraft, capable of carrying both crew and cargo to Mars and returning to Earth for reusability. This reusability is a cornerstone of SpaceX's strategy, as it dramatically reduces the cost of space travel, making it more feasible to send missions to Mars on a regular basis. This reusability is key to making Mars colonization economically viable, significantly reducing the cost of transporting people and supplies between Earth and Mars. By reusing the same spacecraft multiple times, SpaceX can lower the overall expenses associated with interplanetary travel, making the dream of a Martian colony more attainable. Beyond transportation, SpaceX envisions Starship playing a pivotal role in establishing and expanding the Martian colony. The spacecraft's large payload capacity will be essential for delivering the necessary infrastructure to Mars, including habitats, life support systems, and scientific equipment. Its ability to transport large payloads will be crucial for delivering infrastructure, equipment, and resources to the surface of Mars, enabling the construction of habitats, energy systems, and other essential facilities. This will lay the groundwork for a thriving human settlement on Mars, capable of supporting a growing population. SpaceX's ambitious plans extend beyond simply reaching Mars. They aim to create a self-sustaining city on the planet capable of supporting a large human population. This city would be equipped with all the necessary amenities for human life, including food production, water supply, and energy generation. This vision requires overcoming numerous technological and logistical challenges, but SpaceX's unwavering commitment to innovation and its track record of achieving seemingly impossible feats make them a driving force in the pursuit of Mars colonization. With each successful mission, SpaceX brings humanity one step closer to becoming a multi-planetary species, opening up new possibilities for exploration and survival beyond Earth.